In this video we are going to see collections in C#. We are going to work with a program called postfix expression value evaluation. So we are going to evaluate the value of a postfix expression. So first thing we are going to read the input from the user. So this is where I read the input, and while reading the input, I'm asking the user to enter a space between each symbol so that I'll be able to split the string based on the space and store it in a string array called IMP. So I'm going to traverse across the array and process for each symbol. So I have enclosed this one in a try block. So int.parse raises an exception if the string C in the input, if the symbol in the input is not a number. So that is an operator like plus or minus, then will be coming to this catch box. Otherwise we'll be pushing that one into the stack. The statement executes only if this statement is perfectly executed, right, without any exception. And so if that is a number, then we'll be pushing into the stack. Otherwise we'll be coming to the catch block, and here that is an operator. We're going to pop two elements from the stack to perform the operation. Fine. So this is the operator 1. This is while popping and converting the pop object into the into the string using this toString method. This is storing the operator 1 variable. The second element is stored in the operator 2. So now based on the symbol, if that is an operator, only will be coming here, right? So if that is plus, then we'll be pushing the added value into the stack. If the minus, then we'll be pushing the difference between the two operators into the stack. And that's it. Now finally the result is stored at the 0th index of the stack, right? So if we just pop one element from the stack, then we'll be able to get the result of the postfix expression. So now we'll run this code, check for the output, enter a postfix expression with space. Now 3, 4 space, you can see the result is 7. Now we'll run again. 2, 5, 4 into, and this is one operand, and now we'll add this to 3, 7 plus the result is 10. So the 2, 4 multiplication is 8, and 8 plus and 3, 7 we'll be getting like 10, and this again. 3, 7, and both of these are added, and now we will perform plus again on these two operands. Now the result is perfect. This is correct. Now this is 8 and this value is 10, and when you add both, you will be getting the result as 18. This is the first program about the postfix expression evaluation. Now coming to the second question, that is to convert an infix expression to postfix. So will be given with an infix expression, so we'll have to convert that into a postfix expression based on some rules. So here we'll start from the main function. So we have instantiated a stack. We are going to make use of a stack in this program also. So we are prompting the user to enter the infix expression with space in between, just as the case in the previous program. Now using the split method, and splitting each symbol based on space and storing it in array, and have an empty string postfix expression. This is where the result is going to be stored. Now we are going to process each symbol in the input. Now if the symbol is open parenthesis, we are going to simply push that into the stack. If that is closed parenthesis, we are going to do some operation like we are going to pop out until we encounter open parenthesis. Fine. So peek function is just used to return the content present at the top of the stack. Now converting that into a string using a toString method, that is not equals to an open parenthesis. Until then we are going to pop out from the stack and add it to the postfix expression. Now once the count of the stack is 0, then we are going to break. So because if the count is 0 and if we still perform the peek operation, then we will be getting an error. So this condition is used to avoid that. Now after that, so once you encounter an open parenthesis, this value is going to be terminated, right? So if the count is 0, then we are going to break. Otherwise, and also we have to delete the open parenthesis from the stack. So this is a pop operation for that. And otherwise, if the symbol encountered is any of these arithmetic symbols, plus, minus, and multiplication or division, or this power symbol, and in that case we're going to check for the precedence. Fine, this is the main condition. we're going to check for the precedence and insert into the stack. So if the precedence is if the precedence of the operator that is going to be inserted into the stack must be greater than the precedence of the stack precedence of the operator that is already present in the stack. So if the precedence of the already available element in the stack that is written by using this peek function, so if that is less than the presence of the new symbol, then only in that case we will be pushing the symbol into the stack. So to check the precedence, we have a function called check precedence, which I have defined here. So this takes an operator as an input and returns the precedence value based on the based on this if else ladder. Now, so here we are checking the precedence, and in that case we will be pushing the operator. Fine. So otherwise we have an exceptional condition here. If the count is 0 and if the string if the stack contains an open parenthesis alone, only one element, so in that case also we will be directly pushing the operator without checking any checking for any precedence or something like that. So in that case we will be skipping the iteration using this continue statement. Now otherwise, if the precedence is not matched, like if the precedence of the operator at the top of the stack is already greater than the precedence, greater than or equal to the precedence of the newly coming this operator, newly coming this symbol, then in that case we have to so in that case we will have to pop out the symbol from the stack and add it to the PostFix expression. So fine. So once the count of the stack is 0, then we will be breaking the loop, and also we'll have to push the the newly coming operator into the stack using this push operation. Otherwise, then in that case this is for the operator. Otherwise, if we encounter any other symbols like variables, in that case we'll be just adding to the PostFix expression itself. Fine. So and after that, if any content is still present in the stack, then while still stack count not equal to 0, then we'll be popping that from the stack, converting it to a toString and adding it to the PostFix expression. So all the remaining content will in the stack will be added to this PostFix expression. So finally will be printing the output as PostFix expression, and whatever the value that is stored in PostFix expression string, that will be printed. Now we'll run this code and check for the output. For example, 2 plus 4, you can see the PostFix expression is 2, 4 and plus. Fine. So now we'll check with some other input. 2 plus 4 minus 3 by 5 into, here the PostFix expression is 2, 4 plus 3, 5 divided by asterisk and minus. So this is the equivalent PostFix expression for this input expression. This is about the PostFix infix to PostFix conversion using stack. Now we'll go to the next program, that is implementing a doubly linked list. So first thing, we have to include the namespace called system.collections.generic. In that, which contains the implementation of this doubly linked list class, and fine. Also, we'll start from the main function here. So here we have a linked list of type generic, that is that contains only string data. Fine. So and also we have an infinite loop here to perform the operations insert, delete, display and exit for the double linked list, and this is where we read the input. And for insertion we have another sub operations like insert at the beginning, insert after a node, at the end, and this is to return to the main menu. To return to the main menu. Now if input is 1, so we're reading from the input from the user, the data that has to be inserted at the beginning. So using this add first method on the list, this is nothing but the reference of this linked list object. Right. So using this add first method, we are actually adding the data to the linked list, and after that, each time you do the addition operation, we are going to just display the linked list. Right. So using this display method, we are going to see the display method now. So here is the display method. So this takes the linked list itself as a parameter. Fine. So it is going to print some stuff like current W linked list, and so I'm going to just represent W linked list in this form. So I'm going to take an empty string initially and append all the linked list items. This is how you iterate over a linked list and add all those items to this empty string. And after that I'm going to remove the last 3 characters from the string, because this cannot come after, at the end of the string, right? So that operation, and after that I'm just printing the empty string as a list. Whatever the value that is present over the list, then that will be printed. Now that is about the display method, and if the choice is true, then insert after a node. So we have a method called add after. So that's it. Now first thing, before inserting after a node, we need to find the node. If the node is present, only then we'll be able to insert after that node, right? So we have a method called find in the over the linked list. So we just have to pass the node after which the data has to be inserted. So if the value is not null, if that is not equals to null, only then we'll be able to insert the data into the linked list. We're reading the data from the user, and using the add after method, we're inserting the data into the linked list and calling the display method. Otherwise, we can print a method called data not found. That is about insert after a node. Now coming to the insert at the end, we need not check for any check for the availability of any node. We can directly use a method called add last over the list object and perform the operation. Now coming to the fourth operation, that is to exit from the loop. So we are breaking this infinite loop, and that's it about the insertion. Now coming to the deletion, we have remove method, and second option is to exit from the infinite loop. So here will be we have a method called remove on the linked list. So we're going to directly pass the data that has to be removed, and once it is removed, we'll be calling the display method, and if the input is true, then we'll be breaking the infinite loop. Now we'll run this code and check for the output. Insert at beginning, for example the data will be inserted, for example 10, and current double linked list is 10 as the first node. Insert after a node, insert after 10, data will be inserted is 20. Now the double linked list is 10 and 20. Now insert at the end, insert at the end 40. Now if we just go to the 4, that is main menu, and if you just delete, remove 20, then now the double linked list is 10 and 40. So this is how we'll be working with the collections in C#. Thanks for watching.